Hello, ladies and gentlemen, it's Mrs. Taylor. It's been a long time since Blended Learning Day when we did section 8.1, and rather than hang you out to dry, I wanted to make certain that you saw this being done the correct way, i.e. my way. So we're going to do problems 15 through 17 and then, 24 through 26. So the first set of directions for 15 through 17 says write a similarity statement comparing the three triangles in each diagram. So if you look at number 15, I have one large triangle, MPN, and I have two smaller triangles. So when I like to do this, I like to be consistent. So pretty typically, I'm going to start with the right angle and I'm going to go across the short leg and then across the hypotenuse. So if I look at the big triangle, the right angle is at angle P. I go across the short leg, M, and then across the hypotenuse to N. And I can say that that is similar to, and now I'm going to look at the very smallest triangle because it's on the left. So I'm going to start at my right angle, which in this is at Q. I'm going to go across the short leg to M, and then across the hypotenuse to P. And I'm going to say that those two triangles are similar to, let's look at the medium-sized triangle. I'm going to start at my right angle, which is Q. I'm going to go across my short leg to P, and I'm going to go across my hypotenuse, which is N. So that's the similarity statement for number 15. For number 16, let's take a look at this one. I've got three similar right triangles. I'm going to start with my right angle in my biggest triangle, and I'm going to go down across my short side. So my right angle is at A, across my short side will take me to C, and then across my hypotenuse will take me to B. That triangle, let's look at the triangle on the left, so the medium-sized triangle. Again, I'm going to start at the right angle, which for this is going to be D. I'm going to go across the short leg to A, and then across the hypotenuse of that triangle to B. All right, so DAB. This one might be a little bit different. So that's that setup. All right, lastly, we're going to talk about the smallest triangle. In the smallest triangle, we're going to start at our right angle, which is at angle D. We're going to go across the short side to C and across the hypotenuse to A. So that's the similarity statement for that one. Now for number 17, same deal. We're going to start with the big triangle. We're going to go to the one on the left, which is going to be the smallest triangle, and then the medium-sized triangle. For my biggest triangle, I'm going to start at the right angle, which is S. I'm going to go across the short side to R and across the hypotenuse to U. That triangle is similar to, now if I look at the smallest triangle, I'm going to start at the right angle, go across the short side and across the hypotenuse. The right angle is at T, across the short side is going to take me to R, across the hypotenuse is going to take me to S. And I'm going to say that that triangle is similar to the medium-sized triangle. For this one, the right angle is at angle T. I'm going to go across the short side to angle S and across the hypotenuse to U. You can see how quickly I can move doing this if I remember to stay consistent. If I stay consistent, I can get where I'm going a lot more quickly. All right, let's move on. We're going to find X, Y, and Z for these. Now, I have a couple of different triangles. On Blended Learning Day, we learned some ratios, and truth be told, I have a feeling that it's just going to be easier to use what you know about similar triangles in order to solve this. So I'm going to talk about some triangles here. So my big triangle, I have, let's see, think about how I want to do this. So on my big triangle, I have my long leg is Z and my short leg is 12. Let's take a look at what I know about my smallest triangle. In my smallest triangle, my long leg is Y and my short leg is 4. It's not going to get me much. In fact, now that I look at this short triangle, I think there's probably an easier way to figure out what y is rather than trying to set up ratios. I don't know about you, but I'm looking Pythagorean theorem for that. A squared plus b squared equals c squared. C squared is always the hypotenuse. The hypotenuse in this is 12, so 12 squared. And then I have y squared plus 4 squared. So y squared plus 16 equals 144. I'm going to subtract 16 from both sides. y squared equals I'm going to check on this because honestly, I just don't trust myself working on the spot. Sure looks right though. All right, so I want to do 144 minus 16 and check that math. That's 128. All right, I got that right. And I have to think about what the biggest perfect square that goes into 128. So I'm going to start by looking at, oh, I wanted to start at I wanted to divide 180 or 128 by 2 and look at that. And when I divide by 2, I get 64. And as it so happens, 64 is a perfect square. So I'm going to say y squared equals 64 times 2. I'm going to take the square root of both sides. And the square root of y squared is y. The square root of 64 is 8. And I cannot simplify the square root of 2. So my final answer for y is y equals 8 times the square root of 2. So that's good to know. So I'm going to write this in, 8 times the square root of 2. All right, so now I have this triangle right here where my hypotenuse is 12, my short side is 4, and my long leg is 8 times the square root of 2. And then I have this other triangle where my short side is 8 times the square root of 2, my long side is x, and my hypotenuse is z. All right, so now I can set up some ratios. I don't have enough to use the Pythagorean theorem for this. So I'm going to say, I don't know about you, but, oh, I don't know about you, but we're not going to be able to avoid the 8 times the square root of 2. So I'm going to take the hypotenuse of the small triangle and put it over the hypotenuse of the big triangle. I'm going to take the long leg of the the small triangle and put it over. No, I'm not. That doesn't get me where I'm going, folks. Look, I still have two variables. So this is not the way I want to go. So what I want to say is 12 over z, so the hypotenuse of the small over the hypotenuse of the big. But let's look at the short leg of the small over the short leg of the big triangle. And that's going to be a little bit easier for us to deal with. Because I look at those ratios, I know that I can, let's reduce this just to make my mental math easier. 12 over z, and this is 1 over 2 times the square root of 2. All right, so I'm going to cross multiply. Z times 1 is just z, and 12 times 2 times the square root of 2. 12 times 2 is 24. 24 times the square root of 2. And since I simplified that before I did anything else, my answer for z just pops right out at me. So now I come over here and I say z equals 24 times the square root of 2. And now I'm going to use the Pythagorean theorem to figure out what x is. So I say x squared plus 8 times the square root of 2, quantity squared, equals 24 times the square root of 2, quantity squared. All right, so that tells me x squared, 8 times the square root of 2 squared is the same thing as 8 times 8 times 2. 8 squared is 8 times 8. The square root of 2 times the square root of 2 just gives me 2. Over here, I've got 24 times 24 times 2, because the square root of 2 squared is 2. All right, and this should be a plus sign right here. So, all right, I have x squared. 8 times 8 is 64, and 64 times 2 is 128. And I don't know what 24 times 24 times 2 is. So I'm going to pop into my calculator, say 24 times 24 times 2, and that gives me 1,152. 1,152. I'm going to subtract 128 from both sides. I'm going to come back to my calculator. and I'm going to type in minus 128. I'm going to cross my fingers for a good looking number, and I get 1024. And you know, just on a whim, we should always just take the square root of what we're given. So I'm going to hit Control square root, and then I'm going to hit Control answer, and then I'm going to hit enter. That automatically plugs in 1024 under the radical sign, and that tells me that the square root of 1024 is 32. So x equals x equals 32, and those are my answers. I end up for number 24, I end up with x equals 32, y equals 8 times the square root of 2, and z equals 24 times the square root of 2. And I could have done that a different way and ended up with the exact same answers. I could have done different similarity ratios to get me started. I could have used those geometric means that we learned on Blended Learning Day, but I'm still going to get to that answer. Now, number 25, we actually did most of that in class. So instead of wasting time on the video, I'm just going to go on to number 26 and see what we can do here. All right. So automatically I look at this and I see 3 triangles, but I see this one is the one that pops out at me. And I like this one because I can use the Pythagorean theorem to solve it. So I can say 9.6 squared plus 12.8 squared gives me y squared. All right, I'm going to run to my handy dandy calculator, and I'm going to say 9.6 squared gives me 92.16. 92.16. 12.8 squared gives me 163.84. 163.84 equals y squared. I'm going to come over here and I'm just going to hit, no, I'm not going to hit minus. That's not what I want to do. I'm going to hit plus. It's going to start me out at 163.84, and to that I'm going to add 92.16, and that's going to give me 256. The good news is, when we were working with squares, 256 was a number that we wrote down, so it should seem kind of familiar. If not, you're just going to come over to your calculator, do second square root, second answer. That's going to plug in 256 under the radical. When you hit enter, you end up with the square root of 256 is 16. So we get y equals 16. Oh, I love it when we start out with something nice and easy. All right, now the problem is we're stranded. I only have, for that smaller triangle, I only have one value, so I cannot use the Pythagorean theorem again. So I'm going to come over here and I'm going to draw my right triangle that I know all the sides for. So my short leg is 9.6, my long leg is 12.8, and my hypotenuse is 16. Over here, when I look at this triangle, I'm going to shift it around and I'm going to draw it like this. So I have my right angle down here. My short side is Z. My long side is 9.6, and my hypotenuse, remember your hypotenuse is always the side opposite the right angle. So that's going to be X. So now I need to write some ratios that are equivalent. So let's see, obviously I need to use this and this. So I'm going to say the long leg of the big triangle over the long leg of the little triangle equals, and it totally doesn't matter where I go from here, but I'm going to do 16 over x. So I'm going to say the hypotenuse of the big triangle over the hypotenuse of the little triangle. And we're going to cross multiply, end up with 12.8 x equals, well, I don't know about you, but I can't do that in my head. So we're going to come over here and we're going to say 9.6 times 16, and that gives us 153.6. 153.6, and then Drats. I apologize. This is one of those. All right. Then I'm going to divide 153.6 by 12.8. Oh, look at that. And 12 pops out. So I'm going to come over here and divide both sides by 12.8. And I get 12. That's awesome. All right, and lastly, I need to do something to get me z. And I can do a ratio, or I can do the Pythagorean theorem. And honestly, because I don't like reducing radicals, I am going to do ratios. So this is what I'm going to do. I am going to show myself enough to get where I'm going. So I'm going to say the long leg of the big triangle over the long leg of the little triangle equals the short leg of the big triangle times the short leg, or over the short leg of the little triangle. And from here, I need to do some cross multiplication. I end up with 12.8z equals 9.6 times 9.6. I feel like we just did that. In fact, we did. That answer is right there. That's 92.16. I'm going to divide both sides by 12.8, and that will allow me to know that, let's see, 92.16 divided by 12.8 gives me 7.2. Z equals 7.2. All right, so my three answers for this are x equals 12, y equals 16, and z equals 7.2. And those are your answers for this problem, and that concludes today's homework help.